Sure. Thank you, Tom. Just to check, can you hear me? The most standard question these days.
Yes, we can all hear you, no problem.
Okay, perfect. So I'm gonna quickly share my screen. Right, there you go. Cool. Awesome. So I'm Srushtika Neelakantam, and I work as a developer advocate for a company called Ably Realtime. For those of you who haven't heard of Ably, it offers a pub/sub messaging infrastructure as a service, so you can use it to build any sort of real-time or live sort of applications, like chat or location tracking or multiplayer games, right? So at Ably, a couple of months ago, we hired my new boss, Ben Gamble, who's the head of DevRel, is really passionate about games. And every day, because now we're working in a remote sort of scenario, we have these daily stand-up calls, and in every call, he would just talk on and on about how he loved building this game in his free time, or this game he played, and all this interesting stuff that is happening in the game world. And I, on the other hand, have never really played any games, and let alone building any games, right? So just to understand at least the jargon of whatever was happening in that game dev world that was getting Ben so excited, I thought, why not build a game myself, also a multiplayer one, because hey, I work for Ably, I'm a dev advocate, so I should be able to, put some pub sub stuff together and have these things communicate with each other, right? I thought it's just gonna, be an evening project and it should be okay. I mean, not an evening one, just for a day, but you know how it is. Guess what? I was wrong. It's not as easy as it sounds, because it's not just in games. It's not just the point of getting all of these different entities to talk to each other, but it is absolutely necessary to do that in the most efficient way possible. That is because if you think about it, games are nothing but, continuous loops running all through the duration of the game, in which all of the game objects that are present on your screen are basically discretely being moved from one place to the other as part of that loop. So in a sense, if you think of a kite that needs to move from, say, a bottom position to the top position, in that continuously high frequency game loop, continuously running high frequency game loop, you would take that kite and say, hey, just append the Y position of it by 0.2 points or something. And then because it's running so fast, it will basically look like it's a moving kite that is just flying through the air. It'll look continuous, like a video game, but as you know, it's not. And this whole game loop thing is not just on this object, but if you think about this game loop being applied to every other object that's present on the screen, you can start to think how complex it makes everything. And as if this is not complex enough, I thought of introducing this concept of, updates being received from the network, making it multiplayer so other people can collaborate on the same game. So you're taking this high frequency loop, getting data from the network, and then updating all of these things. So I was like, okay, I can't do this. This is just out of this. But thankfully, again, Ben showed me that there are, predefined design patterns and, different architectures in which you can make, most efficient architectures out of this sort of communication strategy and build a multiplayer game, because obviously these kind of games already exist and people are doing them in production. So I then thought of making, okay, my slides are moving. Okay. So I then thought of building, taking the classic game of Space Invaders and making a multiplayer version of it using Phaser 3 and Ably. So in this talk, I'll show you how I built this game and what are the different caveats to, building your own multiplayer game. I'll quickly talk about, the rendering and moving all of these objects in your game area. But I'll largely focus on the networking part of it, different strategies in which these different entities can communicate with each other in order to make sure, the game is still in sync for all the players and they can just, collaborate live. And you can also make this game production level directly scalable, whatever you want, like a real game of Call of Duty or something. See, I know a bunch of game names now. So before we go on to, all of the things that are behind this game, you need more context to understand whatever I've been talking about from the beginning of my talk. So what better than to actually play a live game now live. I'll just share a link and we can all play this together. I hope you'll join. So I'm just going to quickly share the link of the game in the chat box. If you're on a computer, you can visit that link. What I'll do, okay, one other thing I forgot to mention is that I will, as a bonus at the end of the talk, I will also talk about Node.js worker threads, which was released as a stable version only recently earlier this year. I'll tell you how I used Node.js worker threads to create sort of game rooms. So simultaneous game rooms can be running on a single Node.js server. So I'll tell you all about that. If you can go visit that, I'll create a room and share a code that you can use to join. So I have my room link there, and beware, I have not added sound as optional. So if you have headphones on full volume, please be aware of that. So this is the room code that you can enter in the join tab. Because I'm the host of the game, it gives me a button to actually start the game when enough people have joined. And yes, there you go, people are joining. And you can use your left and right arrow keys to move left and right for now until I start the game. But even when I start the game, you can just move left or right according to where you want to be. When I start the game, there will be a shooter shooting bullets. And the idea is to make it to the end of basically the bottom platform without getting killed. All right, so let's see how this goes. And as you can see, this is sort of like an flipped version of the actual Space Invaders, because we're the invaders in this case, not actually the shooter. So I'm gonna wait a couple of more seconds to see if other people are joining, and then we'll start the game. Okay, cool. So let's go for it. So I'm gonna start the game. Be aware, the shooter is just gonna start shooting bullets. So be ready, and I'm starting the game. People are already getting killed. For the person who built this game, I'm actually not great at this. So I always get killed. Let's see, we have 2 people left. I already died. Let's see if, oh, there you go. Someone's dodging really, really nicely. And the shooter is basically randomly changing directions and speed. So you have no predictability into that. Almost there. Come on, whoever this is. There you go. Okay, P, you could have chosen a better nickname, so we knew you won, but whoever P is, you won the game. Congratulations. And Tom, you're second, and Obi, you're the second runner-up. All right, awesome. So I hope you had fun, and I hope you have a bit more context to whatever this multiplayer game thing is that I've been talking about. So let me get back to the presentation and tell you how this is built. Oh, I never actually showed the URL. Never mind. So for any of these, sort of multiplayer games, what I realized was that you can break the whole thing into 3 core components. The first is, of course, the assets. I have, these avatars, you have the audio playing when the bullets are being shot, etc. You need a way to efficiently load these assets from wherever they are, on the internet, on your disk, wherever. You need to keep them ready to show on your game screen whenever you need it, according to your game logic, or remove them or play animations and things like that. So that's one of the aspects. The next one is, how we have physics laws in the real world. If I throw a ball from my rooftop, it'll actually fall down because of the gravity. Similarly, in all of the games, the way different objects work and move around and interact with each other will depend on the physical laws of that game itself. And you need some sort of a physics engine to actually define those laws and make sure that these game assets are adhering to that set of rules. So that's the second core component. And the third one, which is the most important one when it comes to multiplayer games in particular, is the networking. Now, as you saw, we all played the game, and it was completely 100% in sync. There was never a point when I was looking at something else and, another player was looking at something else, because in that case, it would be out of sync. And then I would claim as a person to have been dead. And on the other person's screen, it'll look like that person is still alive. And it's just a whole lot of confusion. So you can't have that in this sort of a multiplayer game. So that is, as I said, that is something I'll majorly focus in this talk. But for the first 2, assets in physics, in this particular game, Space Invaders, I've used library called phaser.js. And it is very useful because it straight away solves the 2 out of the 3 problems that I just talked about. It gives you ways to quickly load assets and show them in a game area based on canvas on HTML5. It uses the web graphics library to actually render them. But basically, you can use Phaser and tell them, hey, I want this avatar to be rendered at this location when this game logic happens. And it'll just do that for us. And it also has a bunch of physics engines. So we don't have to, calculate mathematics from scratch, define what happens from scratch. You can just tell Phaser, hey, when the bullet and the avatars collide, you can just play the explosion animation and then kill all 3 asset objects, right? And Phaser will do that for us very easily. That's it. Our job there is done. So let's take a look at a bit more depth into how Phaser actually works. You start off by defining a configuration object. This is basically how you want your game canvas to be, the size of the canvas, the styling of the canvas, and which game engine, because Phaser has multiple game engines. You can also define which game engines it needs to use, and also you'll define the list of scenes that you want to play in your game. Because in this game that you just saw, we had just one screen, we had a single scene. So that would be something like this, which is the class. It extends the phaser.scene object, and inside this class, there'll be 3 default methods. The first one is preload. Now this is very handy because what it does is this is where you specify all of the different game assets that you will need at any point in the game. You'll just preload them, keep them ready to go as soon as you need them according to your game logic. Because at the time the game is already playing, if you want to fetch a resource from the network and then show it, it adds up to a lot of lag. And you can't really afford lag in games because it's just a horrible experience, right? So in the preload method, you define all of these assets and you can tell them, hey, I want this asset to be rendered at this point, etc. Then there is the create method. Create method is sort of like an initialization method where you define all of the animations, sounds, initialize a bunch of variables as you need in your game, etc. Now, the third important method, this is the crucial one, is the update method. Now, as I was talking about in the beginning of the session, update method is the one that runs in a loop at super high frequency. And in this method is where you specify any updates that you want to do to your game, like moving the positions of already present objects, adding new objects, removing objects, anything that you want to do. Just in update, you check for a condition and do whatever you need because it runs in a continuous loop. Right, so let me quickly show you how this is in the actual game. So this is a front-end script of the game. It's on GitHub. I'll share the link later. But don't worry about all of this code that you're seeing right now. I'll explain that in a bit. But all you need to know is that there is a game object, configuration object here, which defines all of the different things, as I said, about the canvas. It also lists the different game scenes. Right now, I only have a single scene called the game scene, and this is defined here. Now here I have the preload method, which loads a bunch of sprite sheets from different places on the internet, specifies its dimensions and things like that. Then there is the create method. In create method, as you can see, I'm initializing a bunch of variables. I'm also defining how different animations need to play at what rate and things like that. And then we have the most important one, which is the update method. In this, I'm updating different objects based on whatever is happening according to my game logic, which also I'll explain in just a bit. But this is essentially what you need to know for now. And as you can see here, after this is all mentioned, you can just launch that game by calling new phaser.game and passing the configuration object that we created initially. Awesome. So that's pretty much about the assets and physics part of the game. Now let's get into the fun part, which is networking for the game. Now, when I wanted to make the game multiplayer, when I was building it initially, and I had no idea how to build games, I thought, okay, so really it leaves me with 2 basic strategies. Like if I think of a brute force approach, I could either send a message to everyone who's playing with me in the game, whenever my position changes, I can just say, hey, my position is now 10. Hey, my position is now 10. And I can do that for every player that is, that needs to know that information. Or I could sort of have like a channel. I'll talk more about what channels mean, but just conceptually, you can think of it like a pipe where I've published some data, and all of these other players are just picking that data from that pipe because they're also participants on that pipe. But even so, this gives rise to two different problems. The first one is the peer-to-peer approach, where every player is publishing their data to every other player, which means for in a scenario in a game where you have n players, you have n players communicating with n other players, giving rise to big O of n squared time complexity. And for games which are already so complex and which are already running so many loops and things like that, n squared complexity is just not acceptable, especially in this high speed real-time sort of game scenario. So that was out of the way. And the second thing where a player publishes data into a channel is, let's say I publish my my position, but all of the updates on my screen are happening so fast that after I publish, my state has already changed. And by the time that other people pick up that data from the pipe, I'm already in a different state. So there is a very high possibility that all of these players are out of sync and they don't actually see the same game state at any point of time. So the better way to actually implement this is then to implement something popularly known in game dev circles called the client-server strategy, where, as you can guess, there is a server, which would be the game server, and the game server would be the central authority to maintain the global state of the game, the latest state of the game at any point of time. And the players never talk to each other, but talk only via the server, in a sense that all the players just publish their location to the server, and the server just gets all of this latest data and then collects it and maintains a particular game state object and publishes it back to all of the players. Now, because the server publishes this data, this game state to all the players at the same time, they just use this latest update that they've received from the server to actually render the game, thus making sure all of the players are synchronized 100% up to the closest millisecond or so, which is exactly what we need in this sort of a game, right? Now that that's out of the way of which strategy these different entities will communicate with each other, the next thing is deciding how exactly would this communication be implemented. Now, if you're aware of different communication protocols like HTTP, WebSockets, and MQTT, I'm not going to delve deeper into those protocols because that's a whole other talk to just tell you the differences and what's better in which scenarios, etc. I actually have a lot of resources and other recorded talks on YouTube. You can check that out or ask me questions if you're interested to know more. But if you haven't heard of WebSockets, all you need to know for now in this context is it allows two entities to communicate in a sort of connected fashion. So when you set up a communication channel, the connection remains open for the duration of the app running. This gives both of the entities a way to communicate with each other in both the directions simultaneously. So this is exactly the kind of thing we need, right? We can't actually send a request to get the updated information and then wait for the response to come back and the HTTP cycle closing because it's all stateless, etc. So WebSockets is stateful, the connection is open, and all of the entities can push the data as soon as they have the latest data to any subscribers there might be. Right? And that's exactly what we've used. Now, to actually implement this sort of WebSocket-based communication, I could either, build a WebSocket server from scratch, but instead I used Ably, which is PubSub architecture or infrastructure as a service, because essentially all I need is not just the WebSocket-based communication, but I need the PubSub sort of publish subscribe messaging pattern on top of that. And I also need some other add-on features like, message ordering, reliability, scalability. If I have, more and more players, because I have, multiple game rooms as well, I just want, hundreds, thousands, or even, millions of people playing together online. And I just want that kind of scale and the right order of messages in the order that they're published into the channels. You could instead use, Socket.io, which is an open source framework. This provides, WebSockets communication and also PubSub on top of that. But obviously, you can't really scale with that, and you won't have a bunch of other add-on features that I've been talking about, like reliability, security, and all of these good things that I need. Awesome. So that's Ably. And in the client server architecture that I was talking about before, Ably will conceptually sit there, where the players will now publish their data to Ably, and the server will publish the collated game state to Ably. And they don't have to actually worry about who's on the other end subscribing to that data, because Ably will do the high-speed routing from publishers to the subscribers of data. And conceptually, if you think about it, in most of the real-time applications, there is a concept of channels or topics that I was mentioning before. Essentially, in the whole application, if you think about it, there's a lot of data that is flowing through all the time. But it's not necessary that all of the clients that are involved in the application need to know all of that data. So what you do is you fundamentally break this complete data down into different logical units, and then publish or send them in these different topics or channels. For instance, here, as you can see, there's location channel, which carries location updates, and then job updates channel, which carries job updates. And the customer desktop and the mobile don't have to do anything with the job updates channel. They just need location channel. And on all of these channels, any of the entities which are interested in that data can either be publishers or subscribers, as both, as you need. Now, in our application, in the game application, you can think of one channel that is being used by the server to publish the global game state to all players, and all the players are subscribed to this channel in order to get that update from the server. And then each of the player have their own unique channel where they're publishing their input, which the server is listening to. So if there are 3 players, the server is listening to 3 player channels and then publishing to this other game room based channel for the global state update. I hope that makes sense. And just to give you a bit more understanding of what is actually happening in the data part of this whole thing, Ably has this feature called presence, using which you can track different clients when they get connected, when they enter your game, when they leave your game, etc. So you can just listen to an event called enter on presence on a channel, and then it'll just send a callback saying, hey, this particular client with this unique client ID has entered your game. So whenever a client enters, I'm creating this new player object with all of these attributes, a unique ID, avatar type, color, XY score, nickname, and is alive status of the player. And then what the server is doing is it has an associative array where it is storing all of the players' data as key value objects, just like this. So this object will be there for every player that is part of the game, and the server will just make sure that this array is has the latest data as possible based on the updates it is receiving from all these players, and then it publishes that at high frequency. And by high frequency, I mean 10 messages per second to all of the players who are playing, so they have the latest context at any point of time. So that's the new player object. And if you think of the server that's actually publishing the game state update, now players is the associative array that I was talking about, which is made up of the key value pairs, which is one for each player and their attributes, and the player count at any given point. If the front end clients wants to know how many players are there, you can just have that as well. And then the ship body, because the ship is controlled from the server, not on the front end side. It'll also send the position of the ship. Bullet or blank is because bullets are not shot every time there's an update from the server, is just to say for every 20 updates or so from the server, I want to shoot 1 bullet. So that's just a thing for that. And then just to check if the game has already started, and the killer bullet. Now killer bullet ID is important because each bullet, if you think about it, is a different sprite, right? And you need a way to identify these different sprites, because if my avatar is killed by a bullet with ID A, I need to be able to tell other players that kill the sprite that belongs to Srushtika, but also kill the bullet sprite, which actually killed that player. So I need to be able to track that information, and that's what the killer bullet is for. Awesome. So if you now look at the update method, I think this is visible. Tell me if not, but I'll use a pointer just to make things clear. So in the update method, which I showed you before, which is part of the phaser thing, which updates at high frequency, we'll check for all of the different variables in that game update that we receive from the server, and then we render the different game objects according to that logic. So if I quickly run you through it, avatars is another associative array that's only on the front end side, and this is used to store the actual sprites and the attributes of those sprites. The reason it is only present on the front end only is that because we don't actually need to transport the sprites to all the other players. They can just render them locally, and all you need to do is update the position and other attributes of those avatars, which is anyway present in our game state update that we're getting from the server. So if you see, for every avatar, it basically checks if that avatar, if that player has somehow disappeared from the global list. I'm just going to destroy that sprite and delete it from my local state. This is the front end, by the way, just so you know. And then for every entry in the player's associative array, if you remember, this has a key value pair for every player that is present. There could be a couple of things happening, right? It could be so that I have an avatar on the front end for it, and the player is alive as per the global update. Now, this just means that everything is fine. I just need to update the position of the existing avatar, based on the latest position that I've got. And the next one is if I don't have an avatar on the front end for this player, but the player is alive according to the update from the server, it means new player just joined, which I don't know about. So I just create a new, sprite for that, and then render it on my screen just to show that this player has joined. Now, the third one is if the avatar exists locally, but the server tells me that this player is no longer alive. That means the player just got shot, and I just need to play the explosion, and remove the avatar, the bullet, and just, play the sound and things like that. That's pretty much what this one is doing. And if the game is on, as you saw, after I started the game, that is only when the ship started moving and the bullets started being shot. So if the ship is on, just check whatever the latest position of the ship is from the server update, and then render that accordingly in this method. And there is a method to publish my input, which means I'll have a unique channel for my to be able to publish my input, which is essentially left and right key presses, that will be tracked by the server to update my left and right positions accordingly. And this is true for every other player who's playing the game. They'll have their unique channel identified by their unique client ID, and they can just publish their data. And the server, as I've been mentioning, it'll just collate all of this and then update this game state, the player's object, which is again sent back in game state. So that's how this whole thing is set up. Cool. Now, as I said, as a bonus, I'm just going to click the pointer off. I was talking about Node.js worker threads, right? Now, Node.js released this concept of worker threads, which allows JavaScript to be multi-threaded. Now, this is really cool because now you can run multiple, almost like multiple instances of the same Node.js file in your game. So what I've used this Node.js worker thread is to be able to host different game rooms that can, simultaneously have multiple people in each game room playing the game without any relation or noise from the other room. Now, this is made possible not only with Node.js worker thread, but also with a concept called namespaces in Ably. What it is that, for different channels that are present, Ably allows having channels within different namespaces as well, which means if I have, namespace ABC and PQR, I can follow it by colon and say ABC colon game room channel, 123 colon game room channel, which means these two namespaces have no relation with each other and hence no, access to data from the other room. And I can hence use all of these different namespaces to host different game rooms, and the data is all, separate and it doesn't get mixed up. So to understand how this works, as a host of the game, only the hosts have the capability to actually create a new game room, which they can invite other players to play in, as you saw. So the host of game, say ABC, will tell my main server saying, hey, I'd like to host a game. And because the host has asked that, the server will say, okay, let me create a worker server for you and give you access to it. Now, one thing to note is that the unique game code that I shared was being created in the front end on the host side, which means the host, the main server, and the worker server all have access to this unique game code. And this is the unique game code I'm using to actually make build namespaces for that particular game room, just to make sure everyone is then part of that game room and everyone knows where to go. Now, after the game server is created, it'll basically, on the game specific channel or namespace, it'll come back to the host game and say, hey, by the way, I'm ready to talk. So let's start playing. So now the host can basically detach from the main server because it no longer needs any connection to the main server and completely play the game with the worker server playing the role of this, the authority, the central authority that maintains the game state. And all of the different players who would now join this game using the room code will directly talk to the worker server for game ABC and will have no relation with the server. Now, of course, Node.js worker threads also allow the workers to be able to talk to the main thread, which means every time a new player is entering or dying or any, that sort of number is varying, my worker server will just communicate to the main server and say, hey, by the way, I'm alive and I have 10 players playing in my game right now. Just so a server has these stats and it can, allow people to enter the same game room, or it can check, if a game room doesn't exist or if the game has already started and all of those sort of conditions. So the main thread and the worker thread can thus stay in sync and keep talking to each other. After the game is finished, it'll just, kill. The worker server will kill itself and the control will go back to the server. If a new host comes, a new worker thread will be created and so on. And you can have, multiple hosts starting multiple worker servers at the same time as well, thus giving us the capability of running simultaneous game rooms. If you want to see as if, this is not complex enough, I'm going to show you another super complex architecture, which is this. It's exactly the same thing as that, where there's a host, player, global channel via Ably, talking to the main server, worker one, etc. I'm not going to explain this in too much detail, but it's exactly what I explained in the simpler diagram before. I'll share these slides, so hopefully it will make sense when you look at it after this session, and try to understand what is going on. If you're interested to look at the full code of this project, it's available on GitHub, Space Invaders project. I mean, this is just a shorthand for the actual link. I'll share these links in the chat as well. And I've written a very extensive article series, a 4-part article series, talking everything about rendering of assets, the networking, different strategies, and a lot more caveats than I could cover in this talk. And of course, the step-by-step implementation of this Space Invaders game on dev.to, and that's the link for that, which also I'll share in the chat. Feel free to check them out. If you have any feature requests, feel free to make a PR for the project. And another good thing is that I'm currently working on making generic framework for this sort of a networking architecture to make multiplayer games on the web. So what you can do is, if you want to build a similar game, you can just use that starter kit and just focus on the game part of it and not at all on the networking part of it, because that'll all be built as part of the framework. So keep an eye on my Twitter. I'll be publishing that in the next couple of weeks, and I'll be shouting about that on my Twitter. And hope this was useful and you understood things. If you have any questions, feel free to reach me out anywhere. Thank you very much.
Thanks, Srushtika. That was awesome and really fun as well. It was a good game. Thanks everyone for tuning in. I just want to extend a further thank you to all of our speakers, Danny, Iman, and Srushtika as well. Thanks all for joining. Just a reminder, all the slides should be shared with you tomorrow with a follow-up. And of course, we've recorded this event as well. So all of the code and everything we've ran through, we'll be uploading to YouTube and sending you that link tomorrow as well. So yeah, thanks again, everyone. Next Wednesday, we're partnering up with Coderi for our next event, which is that coding challenge. More details will be sent to everyone tomorrow as well. And apart from that, stay safe and we'll see you soon. Take care.